Today we're going to be talking about a couple different types of simple calculations that we use a lot in biotechnology, like this one, where we're going to be making a 15% mass per volume solution. Now the first thing that we have to remember is that 15% can also be written as 15 grams sodium chloride per 100 milliliters of solution. I can now set up a ratio to get x grams over 72 milliliters. I can solve for x grams by multiplying both sides by 72 milliliters, and I'll get 15 grams of NaCl times 72 milliliters of solution divided by 100 milliliters of solution. This gives 10.8, and then I'm going to check my units. The milliliters both cancel out, so I'm left with grams as my units. Now I'll look at my significant figures. I have two significant figures in the grams, two significant figures in the milliliters, so I have 11 grams of NaCl. This is an example of a dilution problem. Dilution problems use some sort of version of this, C1V1 equals C2V2. You might also see it as M1V1 equals M2V2 if you have molar solutions. But this works really with any solution that has a percentage or concentration or anything else that you might find useful to use for it. So, I have here that I want to prepare 30 milliliters of a 35% isopropanol solution from 91% stock solution. Okay, so clearly what I need to do here is I need to find out what volume of this stock solution I need. So I want to find V1. If I call this C1, okay, so that's the concentration of my stock solution. Now I need to figure out my dilutions, okay? So V1 is my wanted, so I can start plugging stuff in. V1, C1, V1 equals C2, V2. Okay, divide both sides by C1. V1 equals C2, V2 over C1. Okay, that's 35%. times 30 milliliters over 91%. And this gives me a value of 11.5, and if I do my unit analysis, the percents go away. I'm left with milliliters, which is what I want for a volume, right? So that's a yay! Okay, now I do the math. I know that this has two significant figures, this has two significant figures, and this also has two significant figures. So my answer must have two significant figures, 12 milliliters. Here's a problem involving a molar solution. So if I have a molar solution, one of the things that I'm going to need is to convert from moles to mass. In order to do that, I'll need the molar mass of NaCl. It's 58.44 grams per mole. Now, in order to figure this solution out, what I really need is I need the mass of sodium chloride that I'll need to make this solution. So, I need to find the grams of NaCl and 150 milliliters of this solution. And then I can just use dimensional analysis to find grams. This is a 0.75 moles NaCl per liter solution. That's the definition of molarity. I'm running out of space here, so I'm going to continue on the next line. My next step is to convert milliliters to liters, and there are 1,000 milliliters and 1 liter. Now I will use the molar mass of NaCl to convert from moles of NaCl to grams of NaCl. So that's 58.44 grams NaCl over 1 mole NaCl. And then I'm going to go through and I'm going to check units. So moles of NaCl on bottom, cancel with moles of NaCl on top, liters of solution go away, milliliters of solution go away, and I'm left with grams of NaCl. And if I do the calculations, I get the answer to be about 6.6 grams NaCl needed to make this solution. Now, the question isn't quite complete because what I need to do is actually make the solution. So I need to add 6.6 grams of NaCl to about 50 milliliters or so of water. And then I'll dissolve the NaCl, and once it's dissolved, I can bring that solution up to the total volume I want, which is 150 milliliters. This then answers the question.